Yeah, I'm very happy that you made it here.
Yeah, thanks for inviting us.
Swarm. And yeah, let's get started. So first presentation, then afterwards we usually have many questions. We already have some. And then we'll have food. So yeah, good. Let's get started.
Okay, so I'm Anton, this is Rafael, and we're working on the Swarm project. Swarm is a decentralized storage solution. Just to have an idea, how many of you have heard about Swarm or know what it is? Okay, so
that's two different questions.
Okay, so how many of you know what Swarm is actually? No, not many. Okay, so we basically just heard, so maybe this will be interesting to you because it's a very introductory presentation. So yes, a few basics about Swarm. So basically it's a peer-to-peer content addressed storage solution. Its origins come from the early days of Ethereum together with the Whisper protocol and Ethereum. The idea of Web3 basically that people would be able to build decentralized applications. And the Swarm is the storage layer, Whisper is the messaging protocol, and Ethereum is the computation layer, so to say. So basic notions about Swarm. So how does it work? You have chunks, hashes, and manifests. You need to know what those things are so that you understand how Swarm works. So basically, Swarm content is split down into chunks, and chunks are are the building blocks of a Merkleized representation of the content. So basically you have a content, you split it down into chunks, and then you build a content address out of your content. So they're limited to 4K at the moment. We are considering different sizes for the chunks, but at the moment, they're like 4K. They can hold arbitrary data, as well as other Swarm primitives. And the idea of Swarm is that chunks reside at the closest proximity to participating nodes in the network. So basically every chunk has a content address, and the idea is that its position within the network is to the node that has the address which is the closest to the chunk. Then we have hashes. Basically hashes are content address, binary Merkle tree chunk hashes. They're used for the Merkle tree representations of arbitrary data, and they share the same address space as node IDs. So basically when you have a hash, it should live to the closest node ID. And basically the hash of that's just a representation of the hash of a chunk. That seems to be kind of wrong. So basically, files are retrievable using a single 32-byte hash. So basically, when you hash your content, let's say that it's a big file, let's say a 2-gigabyte file, what Swarm would do is it would chunk it down into 4K chunks. It would build a Merkle representation out of it. And the root chunk is what you would use to find your file. So basically, the root chunk would have pointers down to the intermediate chunks, and the hash of the root chunk would basically be the identifier you would use to find your file within the system. So because of that, you have built-in integrity protection. Every time you retrieve content from the network, we check that the hash corresponds to the content. And we also support hierarchical encryption. And then manifest. So manifest basically is the way that we represent paths to content. So for example, if you upload a website to Swarm, the root chunk of that content would be basically the manifest, which presents, let's say, a file system representation so that you know, okay, this website has CSS files attached to it or JavaScript files, etc. We're using a tree representation for it, and basically the manifests provide the main mechanism to allow URL-based addressing in Swarm. So these are the three basic notions of Swarm. So chunks, hashes, and manifests. And this is the base layer of Swarm. Now, on top of that, we also have encryption and access control, so that you can manage permissions of your Swarm hosted content. You can, let's say, encrypt your content, push it to the network. Obviously, you have to encrypt it client side so that you don't have anyone else being able to decrypt your content. And you can also manage permissions with access control lists. So, for example, if you want to give access to a certain content to, let's say, 100 people, you can then just manage the lists of that encrypted content. You don't have to re-encrypt your content if you want to change the list of the encryptions, the list of the permissions. Another Swarm component is PSS. You can think of PSS as something that's similar to Whisper. So basically that's the messaging protocol. So Whisper has full darkness. Basically it means that you encrypt your content and you send it within the network, and whoever can decrypt it, then they know that the content is addressed for them. With PSS, you can do the same thing, but you can also expose part of the recipient address. So for example, in a big network, you can expose, let's say, a few bytes from the address. So nodes who don't even share that address prefix don't even have to try to decrypt the content. So they know that this content, this message is not addressed for them. And then only when you reach the nodes that share the same content address as your message, then they will try to decrypt and process the message that you're sending them. We also have feeds. Feeds is basically used to publish updates for mutable content. This is the functionality that we have so that we publish mutable content on Swarm. With the content address chunks, obviously you need to, that they support only immutable content, and this is where feeds come into place. So if you have a website or let's say a blog, and you want to publish mutable content on it, this is basically a deterministic scheme which tells Swarm where to look for the manifests for the immutable updates, so to say. It's a quite interesting tool which you can use to build dynamic websites on top of Swarm. And the last component, which is basically, I think, one of the most interesting ones, is the swap and swindle component. It's in active development right now, especially the swap part. It's basically what handles the accounting between nodes. So the idea is that when nodes connect as peers to within the network, they measure how many messages they process from other peers, and if this balance goes only one way, so let's say you have one node that's a seeder and another node that's more like leeching, so to say, at some point the leeching node should provide some kind of payment for the services. So basically, swapware and swindle provide the economic incentives to drive the network. And once a threshold is being reached, through a payment channel, you can issue checks to other peers, and then you can cash those checks on the Ethereum blockchain. So basically, that can also provide a reputation metric, so that you build a network only of nodes that you have past relationship and basically good nodes, so that you can make sure that the network is incentivized to work. So these are pretty much the main components of Swarm. I won't go into more detail of that. And I'll hand it over to Rafael, who is going to talk a bit about the tools that we have so that you can build on top of Swarm and understand what your Swarm node is actually doing once you start it.
Yeah, thanks. So I mean, this is the part where me and Anton do most in this Swarm project. We are actually building tools to understand how our Swarm nodes are behaving and how to actually debug them. Because in the past, we do have like a public testnet, which is kind of without incentivization right now, so it's free for all. But it happens that people ask us, why is it slow? Why is my file not retrievable? And we kind of have to answer these questions by having proper tooling around Swarm. So Swarm, of course, it's written in Go. It compiles into a single binary. You can check like all the flags. We handle logs. There are different verbosities that you can configure. We try to, well, right now our logging structures are kind of, but we have to kind of improve them so that we can debug easier in the future. So logging is there. Also, we do make a lot of like private deployments, private clusters within our environment so that we can see like the nodes communicating and debug problems. So this is an example where we gather all logs on Kibana using Elasticsearch and so on. Another important aspect for observability of the Swarm cluster are metrics. So all our Swarm nodes, they have specific metrics for all these different components that Anton mentioned. We can forward them to InfluxDB, which is a time series database. And then we have also nice dashboards for the different components so that we can identify if there's a problem on a given node. And if we identify that, then we can even have a look at the logs and deep further into the problem. And also another very important aspect is tracing of the requests. So when you mainly, for example, when you download a file, your request, it will go through a lot of nodes, and we want to completely understand the end-to-end thing that is happening right now in that network. Of course, in a public network, we can't do this. So we try to kind of reproduce the problems always in private deployments. And therefore, we have tracing also. This is like then an example of a retrieve request where we can measure like times on specific nodes and what kind of functions were executed. As I've mentioned, we have the capability of deploying large clusters for testing purposes. We mainly use, as mentioned before, like InfluxDB for metrics, Jaeger tracing, Kubernetes to orchestrate containers. Helm is basically just a package manager for Kubernetes and the whole logging stuff. And we have custom-made smoke tests where we just verify that the base functionality of Swarm is working. We did a demo in the past where we just deployed 1,000 Swarm nodes just for demo purposes. It worked fine. And here in this table, you can actually see the Kademlia table of one of the nodes. The Kademlia table represents kind of the routing. So you can see that, for example, this current node would have the address of D8 blah, 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 and all these other nodes are, for example, this is pin 0. This is the furthest away nodes that are in here, and this, if the ping gets higher, that's the closer I am to this peer. So yeah. That's mainly it. In 15 minutes, Swarm in 15 minutes, and what we do. Are we on time? Just perfect, right? 14, okay. There are also some useful links. Again, our homepage. This is also an interesting one. You can dswarmgateways.net. These are our this is our kind of public testnet, and you can also access our website through the gateway using an ENS domain under the swarm.eth. So we also have an ENS integration so that you can use names and don't have to use these big hashes. That's it. Questions?
Thanks.
What are actually the main obstacles you're facing? Because I think development already took quite a while.
Well, the main obstacles in like building Swarm, from my perspective, is the lack of engineers on the team. I mean, it's a quite small team, so I think that we're trying to build many things at the same time. Like it's a very big project, and if you only focus on the base functionality of Swarm, I think it's like a pretty big project that even the current team will not be able to kind of solve. But we're also building a lot of stuff on the side because, I mean, that's how it works in an open source. community, so to say. Everyone works on whatever they want to, so to say. So you can't
Regarding
really-
stuff on the side, I mean, why do you implement something which is pretty much similar to Whisper?
So Whisper can't really scale very well because of the way it works. I mean, every node has to try to decrypt something, and this gossip protocol, PSS is much more efficient because it's using the overlay network of Swarm, which we didn't really mention much. So Swarm has this Kademlia overlay network, so you have a notion of where your message is supposed to go. So for example, you can route it very efficiently until it reaches a certain neighborhood in the network, so to say, when the processing needs to start happening. With Whisper, everyone needs to start processing your message right away. And in big networks, that's not very scalable. So for example—
Are you working close together with the Whisper team then?
Yeah,
Yes.
actually we are. Yeah, some of the people who were mostly involved in Whisper also trying to work on PSS, etc.
So the storage is distributed, as you
Yeah.
put it. And how does lookup work exactly?
So lookup—
Does everybody store?
no, so you have this Kademlia overlay network, and
So you use a distributed hash table.
yes, exactly.
That was my second question. Wondering that. So you use Kademlia for lookup, and
Yes,
then
exactly.
the nodes store also the content.
Yes, that's the main difference, for example, to, let's say, IPFS. So there, the node would, when you look up a key, it will tell you where the content is being stored, whereas in Swarm, that's where actually the content is being stored.
I see.
And also you have this replication factor when you get closer to a given address, that's basically this depth in the table, you replicate it within those nodes that fall into depth.
I see.
And how do you create address for the replication? Do you like rehash and have like secondary, thirdary hash, or do you select like second, third, and fourth closest nodes? Like, what is the
Yes,
strategy?
you're checking the second, third, fourth closest nodes. That's pretty much the
that's
strategy. Yeah.
How hashes of the nodes are created?
At the moment, randomly. So
I'm joining network. How my hash is created?
randomly. So you just generate a
I
random.
generate. So I have a power to decide what is my hash.
Well, if you want a specific hash, you would have to kind of brute force it, so to say.
How hard it is to brute force it. That's why I ask about input parameters.
Yes, right now I guess it's not very hard to place yourself within a certain point in the network. The idea, I mean, there are different solutions to that. You can add some proof of work, which basically won't allow you to generate many hashes.
But currently, if I like to sabotage some file, I just take its hash, I generate 10 nodes that have closest hashes.
Exactly, yes, that would totally
and all
work.
content is stored on my nodes, and then I just turn them off, and content disappears.
Yes, that's what would happen right
Thank
now.
you.
So the protection against that would be what's written in the Kademlia paper, the S Kademlia paper.
I know Kademlia very well, that's why I asked this question.
But we don't have this implemented, so that's an idea we are thinking
I know
about.
it's not easy, I work on it.
And the Kademlia implementation that we are using is not really the default one, it's the recursive version. So that's also a difference with, let's say, other systems such as IPFS, for example.
That's good to know. Thank you. Yeah, I look more into IPFS than Swarm in the past. So that's interesting.
Yeah, I'm making the comparison because people generally know more about IPFS, and it's an easy way to understand the
Yeah,
difference.
that's perfect.
Was also so for the access control part, is this encryption-based access control?
Yeah.
So how does this? Can you elaborate a bit more?
So I can't really explain quickly how that works. I know that it has very good documentation. So if you go on the Swarm guide, you can read about it. What I know about it is that basically the base layer doesn't really care if your content is encrypted or not. So a chunk is a chunk. I mean, it's just a slice of 4K. So encryption basically works that you encrypt your content, and also the encryption key is appended to one of the chunks. So then you have a second layer on top of it which handles the access control lists. So at some point, if you want to change the access control list, you don't have to re-encrypt the content. But exactly on which level is what, it's very hard for me to explain.
I see. So you can give access to somebody and then somehow. Okay.
So if they have seen the content, they cannot unsee it. So you can only, let's say, not give them access for new updates, for example.
That has revocation, everything.
Well, you can revoke access, but if they have saved it, I mean, there is no way around that. Yeah.
Okay.
So yeah, you can revoke access in that kind of way, so to say.
Yeah. A follow-up question on the PSS versus Whisper discussion before. You make it sound like PSS is more efficient than Whisper because then it's a gossip protocol. Well, I guess for Whisper to exist, it must give something which PSS doesn't. What is that?
Well, you can implement like Whisper with PSS, so to say. I mean, you just don't disclose any part of the address where you're sending your message to. I mean, you just send like 0 bytes as the address. Then every node in the network will have to kind of propagate your message until it reaches the node who can decrypt the content. The thing is that that's the default behavior of Whisper. With PSS, you can disclose, let's say, the first byte of the address, and then a big part of the network won't even bother to try to decrypt the message. And you can also target it because of the Kademlia overlay network.
Yeah, like scalability question. So I could theoretically store like images on this, right? And have a website that you open and you have gallery of images.
Yeah.
So let's say that those are images coming from, let's say, network of my friends. So this image has different access lists.
Okay.
Because it's shared with different circles.
Yep.
So basically on this page, I may have, let's say, easily 100 photos. And when I scroll down, it automatically generates, in typical fashion, like more photos, like fetch them.
Yep.
So you can get like 1,000 of them. And each of them may have a list of access control. Let's say each of us might have like a circle of friends, like around 100 friends, right? So I just click, I want to share with friends. So then it's like 1,000 photos per 100 personas. It's like 100,000 access control checks per one page. And I wonder how, if this would run on it or would break, or where verification would be run, would it be distributed? Like, would this run at all? Like, yeah.
Yeah, I see your point. You're asking if it's
I don't have a
scalable.
concrete question, but I hope I quite clearly showed the scalability issues that are around my head. And I don't know how it works. I would love to hear for this use case. Yeah.
So it's kind of difficult to answer because that's already on the kind of dynamic content, so to say. I mean, you would want to, let's say, update this photo album as well. So what you would use is some kind of swarm feed for that, so that you have a deterministic scheme. Let's say every minute new update is being posted, people should know where to look for it, and the network should kind of send you to that address. Whether it will scale for 100 of your friends, yeah, that's a good question.
Yeah, I click, I fetch HTML that describes, I fetch those 100 photos, and each of these photos has different access controls. So then you have 100 per 100, like 10,000 access control checks just at the first page, just to show it. And it should show like within 2 seconds for good user experience. I just wonder if it's like visible.
Well, I think it's feasible because just checking the access control list and checking that you are on it.
When does that exactly happen? Yeah, because that's the part I missed.
The swarm node basically will check that. So it will. So you're running a swarm node locally. I mean, that won't work through a gateway because otherwise you have to send your decryption keys to a gateway.
Okay.
So you basically are communicating with your local swarm node, and then you are going to reach, let's say, a hash of a picture that is encrypted. And basically, the swarm node should check your public key if it's on the list, and if it's on the list, should give you.
This list is where it's also with the picture, it's together. So
I'm not sure. I will have to double check that.
Because it defines
it's a different chunk, so it's not with the picture. I mean, the picture itself is encrypted with some shared secret, and the shared secret is somehow tied to the access control list. But yeah, I can't really answer your question.
But those can be fetched in parallel, right?
Yes, of course. Yeah.
So delay-wise, it does not introduce delay. We can fetch the list and the picture at the same time.
Yeah.
Verify it locally. So it will not DOS nodes because it's locally, so it cannot DOS nodes in that way. So it's not. Yeah, okay. I was wondering also about attack vector for DOS. Check locally.
The idea for DOS is that you have accounting between nodes. So if at some point your peers stop paying for their requests, or they, let's say, there are different schemes where you can prevent spam. The idea is that you won't even be peer with those kind of nodes. Obviously, if a new node comes into the network, somebody needs to accept them, and the initial first few requests or some kind of bandwidth, they can abuse that. But you always prefer older nodes in the network, not like newer nodes. So
yeah, like it's just sometimes people like underestimate the price of checking access control list.
That would fall into the swarm feeds, and we're mostly focused on the base layer right now. So it's a very good question that you're asking, but I'm more interested in getting the base layer working.
Absolutely. Step by step. As you said, it's a big system. Thank you. I would love to learn more designs.
But that's a good use case for tests to do like in the future.
Yes.
I think also for the product, it would be very nice to have. So it sounds like it's using discretionary access control where there's an owner or somebody who manages these access control lists.
Yes.
It would be very nice to have decentralized access control where you can have delegation. There's a lot of work on this. It seems like a very nice fit with Swarm. You have decentralized access control as well.
I think you can set that up already, but I'm not really sure. So if you have a smart contract behind that can sign, let's say you have a...
Implements the logic, I guess, of how you manage.
No, that's not what I meant. If you have a... okay, it escaped my mind. Anyway, I'll have to double check that.
Is there any connection currently between smart contracts and Swarm?
That would be the incentive part with the accounting right now. It's in active development, and the idea is that if you reach a certain threshold of messages between nodes, they start issuing checks between themselves. And then each node can decide when they off-chain, and then each node can decide when they want to cash that check on a smart contract.
Smart contract would be used as a payment channel.
Yes. And that's in a proof of concept stage right now. The smart contracts are there, the first version of them. I think it works with Rinkaby. And the idea is that every node then deploys their own checkbook contract, and nodes interact with the other nodes contract. This is not merged to master right now, but I expect it to be merged in the next, let's say, 1 to 2 months.
How did you pick the 4 kilobyte chunk size?
Yeah, that's a good question. I don't know. It's a legacy parameter, and I personally never understood why it's 4K. I know that for legacy reasons, there were ideas to integrate it with Ethereum back in the day. So previously, Swarm was part of the GET client, literally within the same process. But as far as I know, there is no longer any specific reason for it to be 4K. There are interesting reasons for it to be larger. I mean, you don't have to wait for data so much. Yeah.
Okay, let's do one more question. Perhaps also, like, I don't know, the guys remote, of course, you can also speak up. You have anything.
I have another question then. Do you know what academia stands for?
Yeah, it's big in Bulgaria.
Yeah. Right.
Okay, cool. Thank you.
Thank you very much. Yeah, if you have any other questions, yeah, always feel free to join the GitHub channels. So if you go on the website, you can find ways to contact us and talk to us. Or yeah, there are multiple channels.
Thanks.